Good. Okay, this is our project, the GoFer. We're the team Grim Sweepers. We'd first like to just thank faculty and staff for all the help that you guys helped us with on this project. And then we'd like to thank Ed, Roger, and Sean for Jordan to all their patience and guidance that we needed. This is our team. And each of those are their major responsibilities within the team. We'll just go over the project outline again. The GoFer will be an adjustable electric-powered sweeping robot used to clean under the warehouse racking. To push dirt, debris, and obstacles into the next aisle. Will be easily picked up. It will be easy to operate and will reduce the probability of injuries, especially back injuries. The necessity of the project is in distribution centers where racks are used. Cleaning under the racks is a major problem for sanitation and safety. The current system uses push brooms or air, which spreads particulate matter throughout the building and doesn't really facilitate the cleaning process. So here's some of the requirements that we had to abide by. First was the width, which we covered. We were able to keep it under 6 inches. We were able to keep a weight manageable. It's around 170 pounds. We had a pull handle for movement. We had side brooms to clean up under the uprights. We were able to create a chainless drivetrain. It's battery powered. It's UPS shippable. It's broken down into components. It's interchangeable between versions. If we have a standard version, first heavy-duty version, how many battery packs, and also how powerful the motor. Make it fairly easy to manufacture. A lot of standard machining equipment. Try to limit milling operations, and we made it strong for industrial use. This is where we started at the beginning of this second semester. This is what we designed first semester. And this is the final product for this semester. And there's a picture of it. So I'll go over what my major responsibilities were for this project. One of my responsibilities was purchasing material. This is an example of kind of a purchase list that we go through, and when it was ordered, who was ordered by, when we received it, and who received it. I was also over conducting the meetings, and this is kind of an agenda that we have every meeting. We go over assignment progress with everybody on the dates to be completed, new assignments made, and who's going to complete those assignments and when to be completed. I also had customer interaction, so interacting through emails, phone calls, text messages, face-to-face meetings, and live testing. Another responsibility I had was wiring. We had the issue where we needed to have a forward and reverse for a DC motor, and so that was the wiring. We came up with 5-pin wire. So lessons learned. One of the things I learned was procrastination just creates less quality, creates more problems, creates more time. I also learned that if you have scheduling, it's always evolving, and it always needs to be maintained and supervised over where it gets out of control. And then the last is, an easy fix is never easy. Every time we make a change, it took something that was simple, like changing a bolt location, seemed to take forever and ever and ever. But I learned that it was pretty fun too. So I'm going to have Brian come talk about this portion.
All right, my main responsibility was over the machining of all the parts. And I have 4.5 years of machining experience. I'm currently working at a machine shop. So I did most of my machining at the shop I work at currently because I'm really familiar with machines. This is the main machine I use, the Sharp Mill, and it has an Accurite milling computer, X and Y movement. So I'm able to do contours, pockets, or whatever, just programming it on the machine itself. explain a few of my setups that I did. The first one is a pin guide bracket that for the drop-down casters for the locking pins to lock in. And all I did with this is we just needed 2 of them, so I clamped them both down to the table at the same time. Clamped one side, roughed it, finished it, and then put clamps on the other side, roughed it, finished it on the other side. So it made it pretty quick, simple and easy. This next one is the front sweep holder. It was quite long, and all I had at the time set up was just a single vise. So all I did is I cut a slot, slid it, pinned to it, and made that my 0 location. Then just kept moving along until I had all the slots done. It made it really easy since there was only one that I needed to do. And then there's another picture of just showing that I'm pinning to it to find the next 0 location to mill the next slot. And this one is the subframe, the cross member. And this is kind of overkill. You really wouldn't need 3 vices set up, but we just had it set up from a previous run of a part, so I just kind of utilized it, made it easy, was able to get the full length of it. And just pretty much that, just had center drill and drill holes all around it. Lastly, these are the slides that would take up the slack between the telescoping tubes. But one of our ideas was to put pieces of plastic, and they were only going to be 140 thousandths thick, so to keep a good consistent thickness, I actually just taped it down to the bed of the table of the mill and face milled both sides to make sure it was equal thickness all the way around. And then just did other things, sandblasted the hinges for ease of weld. And some of my lessons learned is organization. We had it was just so hard to find prints, like location of prints. It just seems like you didn't know exactly where they're at, and it would take a lot of time. Next is just to keep an up-to-date parts completion list, because it kept changing, so we just never updated it. So we'd always have to go back and look at the prototype itself to see what needed to be done, instead of having a convenient list to look at to see what was still needed to be completed. And lastly, was to all that small changes take forever. Just like all the additional paperwork you have to do, op sheets, you got to update op sheets, and then just ordering the material takes a long time. So it just seems like small changes where you have to order material takes a lot longer than it needs to. So now I'm going to turn my time over to Carson, the master welder.
Thanks, Brian. When we went into this project, I remember thinking there's not going to be a lot of building, and I won't actually have to utilize a lot of my welding skills. But on the contrary, I think most of this semester, every time we would meet, I ended up welding something almost every day that we did it, and I was shocked how much we actually did have to weld. One of our original goals was to kind of get away from welding, not that I didn't want to do it, but just for the simple fact that it was ease of manufacturability. We wanted to move more towards buy parts, things that we could just pull together, so I would get away from cutting and welding things together, save some time, save some money. With this project, it kind of threw us for a loop because there was a lot of small components, required some actual quite precise welding. The fact that we had a lot of fit-ups together, parts that needed to mate together, and so we had to make the choice whether to MIG weld the parts or to TIG weld the parts. We chose to TIG weld everything because it produces a smaller profile weld where parts could be made up together. Another challenge that we faced is we had a lot of steel components and also aluminum components, and I hadn't had a chance to work much with aluminum as far as welding, and luckily I was taking one of Mark's advanced fusion classes, and we went over welding and how to balance the AC wave and to use different techniques such as that to produce a better aluminum weld. So it definitely came out of this feeling much more confident in my aluminum welding than I did before, which some of the parts that were aluminum we ended up not using, but nonetheless, I feel like I gained that skill and the confidence to better go out into industry, knowing those skills, and to actually take what I learned in class and put it in practice on this project. So that was a definite bonus for me. You can see most of the parts that we did well together. One of the things that we did also struggle with was a heat warpage that went into that. One of the downsides of TIG welding is it's a little slower, so there's a little more heat input to it. And the parts, such as this part of the main frame, we had some guides that slide into it, and they're a close tolerance square tube. And because of these sections that we welded here and there, it actually warped the tube, so we had to do some additional check and streaming and actually get them to slide in and out. So that was definitely something that I didn't think we'd run into, but we did. I thought I knew a lot, but going into prototypes, you definitely kind of come out of it feeling a little bit like an idiot. It's like, how I've been doing this forever. I thought I could have foresaw that, but it never works out that way. So just a little picture. I very much enjoyed this project to do the welding on it. It was definitely something that has increased my skills, and also to get away from what I've been doing in industry and weld something different, kind of develop welds for the first time. The lessons that I learned, not just this one, is patience. I'm the type of person, I hate the paperwork, I hate the changes and the procedures and documentation. I want to get in and build and start making parts that day so I can see the final product. But as we got into this, I realized that my impatience kind of led into problems, because we get in and weld something together, put a part together, and we hadn't thought it through thoroughly enough or been patient enough to see what other parts would come together with that part. And so we'd end up having to redo it or ultimately scrap that part. So that's a big thing that I learned on that. Another one is another lesson that I learned is just following the system. The system of changing things and working with your team and having proper documentation and keeping track of all the details is very important. And if you try to jump ahead and skip those steps, then you end up paying for it. So with that being said, I'll turn it over to Nick.
All right, I was in charge of all the inspections that we had to do. And first thing I want to say about inspections are they are non-value added. Took a lot of my time just measuring stuff, checking it. The hard part about it was the tolerance. When we first started out, the sheet had these really high tolerances, and some of them were off, and so that was one of our biggest challenges on the inspections, were to get them right and to make sure everything would fit properly. This is the sheet I made up. It's kind of hard to see, you probably can't see it. It's just got the part number, the name, the date, if it passes, the type of dimension, the tolerance, and then the actual dimension. Just your standard sheet. And so also, like Brian said earlier, we needed to develop a part status list to kind of monitor where the parts were at, where they were going. And this worked really well for the first half of the semester. Everyone was checking in parts, checking them out, and whatnot. But halfway through, we ran into a lot of changes, and we kind of went away from this. And if I were to do it again, I would like to keep updating this, making it different throughout the semester, not just having one, because the parts change and stuff like that. So it'd be easier to follow. There's just a picture of me machining. I learned a lot about machining. Brian helped me out a lot, as I knows, it can be kind of tricky, but definitely learned a lot. There's just another picture of me at Weaver. Things I learned, like I said, were about the inspection. If I were to do it again, I would make sure that the design is where we want it, because all the parts we changed really took it out on me. I inspected tons of parts that just went out the window, and it just felt like a lot of my time was wasted, and so yeah. I'll turn it over to Eric.
I'm Eric Quinn. I was the
Trigger on the back.
there we go. I was in charge of engineering change orders. Kind of lobbied for this position. I thought it would be an easy one. We designed this thing great. I'll maybe do 2 or 3. It'll be easy. Turns out, 95% of our parts got changed. In some way, whether that's extra holes drilled, something modified. So if you look at the back of our book, you'll see a stack about that. But it was definitely an interesting thing to learn. Kind of an annoying one. There's also non-value added. Here's our change order, the sheet that we used. Up at the top, we just have an engineering change order number just to keep track of it. We just used a 3-digit number, 001 through here up to 54. The date, just the date it was originated. Who was the, can't read that. Oh, who was the originator? Part name, part number, the type of change. There's 2 types of change, either a document change or an actual part change. And the affected assembly, so that we could easily reference it back to the assembly in our SolidWorks drawing. Next line down is just our change requested, just a simple explanation of what needs to be changed. And then the reason it was changed, so when we look back we can see why we changed it. And then who it was prepared by and whether it was approved or not. In the beginning, kind of like the inspection sheet, we did have a sheet that whoever made a change was responsible for updating that sheet. So if I looked at a part and go, we need to add an extra hole to this, we should have updated this sheet, and that should have worked its way through the system in order to get that part changed. It didn't always work out that way. Like Nick said, we had a lot of changes at the very end, and we were just rushing to kind of get done. I think we were match drilling some parts on that. A few lessons I learned on this, I think a few important ones. I would set up, before you start any job, it's important to set up an actual standard operating procedure and the way things should flow through the system. For instance, in the beginning, we should have had it set up with extra bins so that when an engineering change order needed to go in, that drawing would be taken out, be put in that bin marked, the change order would then be put with it. It would work through its way through the system. After it got changed, that would get put in the next bin to flag our design graphics engineers to take that, make the change, return that back to the bin, and then the next person would put that back in. That's how it should have flowed. It didn't always work out that way, but in the long run, it would have made our job a lot easier had it worked out that way. And another major lesson, I think, is what Derek kind of brought up, procrastination at first. And I don't know if it was necessarily procrastination, it was just a lot of work to get done, and there was a lot of changes at the end. But knowing what you're building and spending more time on it, not rushing through jobs, would have made the end result a lot easier to get to. Do you want to kind of share?
Yeah, I was in charge of drawings and meeting minutes as an executive secretary. Obviously, being in charge of drawings, me and Justin actually shared that since there's a lot of drawing